So this is part 5 of the videos concerning this test spring 2014. I'll now look into how we can do the assemblies. In the test we have a sub-assembly between the flange part and the plate, and then we will put the sub-assembly into a top assembly, we will say, where we also add the nut at the cover. But we'll start with the sub-assembly, and I will place up here my first part. I will browse for it, and I've saved it here, and I have my plate already on here, and it's in the window. And the first thing I'll do is actually place it grounded at origin. It's quite often a good idea. See what happens. We can carry on adding. I want to finish here. So my first part is now placed grounded, you see, with that pin mark. And it means actually that we have, you can see the XY plane on the parts, and the startup origin is in the same level, we can see. So that's what it means. So, and it is grounded now. It is not constrained really, but we just fixed it at that specific place, and which is in the startup origin. You can see what happens if we take away the grounding. Then we can actually move it, and you can see we have lost our connection to the startup planes. If you want a proper constraining, we can of course do that later. So if I now made startup XZ plane to the part, apply it. Same for XZ, apply. Also for XY, like that. And if I now apply it, it will probably complain. And this is because I can't make it mated to each other, so I have to make it flush. So I do it again, XY and XY. It works better. So we're now back to the constraining. We don't really need to do the pin marks, the grounding, but we can actually do it. It's quite often a good idea that we ground the first part. Next I will add the flange part, so I place the new one, this one. I just click a random place, and then I can place more if I want. I want to finish here and leave my flange part here. First thing I would like to do, we can do several things here. We can constrain mate that to that one, and then we can add constraints between the planes, for example. So I could do that, or we could also use the joint option. I try with mate option. So onto here. It's fine. Then I would like to mate the planes. Find could be the YZ plane on the plate to find the origin on the flange part. It shouldn't be the YZ plane, but could be yeah, it could be anyway. It could be this XY plane, for example, or XZ. See what happens if I choose XZ. Do it like that. If I choose flush, it will turn it around like that. It's okay. Still, we can see, take it here, we can move it up and down because I haven't fixed it in the other direction. So I can of course do that. So I'll find the plate, correct this XZ plane, constrain that with XY plane on my flange part. Let's see what happens. Not possible, but because we need a flush here, probably. So I'll do it again. Exit the plate. XY on the flange. Seems to be working better. So now we got full control of it. We could choose a different approach. Could also show that if I now take away these constraints I have done, I can simply suppress them if I just want to. And they're still on, but they're not working. So I can now move it freely. If I now instead would like to use the joint option, I could do that. We've got different types. We've got a rigid, rotational, slider, cylindrical, planar, ball. I think actually here it is meant to be welded on here, so it could actually be an idea to choose a rigid option. The first one I'll choose is it's actually the movable part, but and this is the second part. Choose here. Click on that one and click on the surface. You see it is put nicely on like that. And that's actually what I want. We can make some reverse and invert alignment and flip the component, but it seems to be fine here. Press OK, and it's actually nicely done. So it's an easier way of doing it. So this will conclude the first part with the sub-assembly. And we of course need to save it, call it a sub-assembly. Okay, next to do was making the actual final assembly, where we have our sub-assembly here, and we also add the cover and the nut to it. So let's have a look at that. We start up a new assembly, and we'll place the first component, which in this case is our sub-assembly. I've just created it's in here. I place it grounded at origin. Okay, so like that, fine. I'll turn it around so it looks more like what we have on the exercise sheet. So the next or first thing I'd like to add is this cover thing. Place that, move to place area, choose a cover. So on here I just again click a random place. Notice I have painted this red so we can actually easily separate things. There are different ways of doing it. Of course, we can make mate on the surfaces here to that surface and then constrain the holes also. But I guess maybe the easiest way is maybe use the insert option. This one where we are combining two mates, we could say. So let's try that. I pick this edge and insert that to that edge. Something like that. And we can see, if I now cancel it, we can see how we can move it now, like that. So it's partly fixed to each other. So I need another constraint here, and you put on an other insert. This edge to find that edge in there. This one, and it's okay. And it's actually do the job for us. So that's, I guess this is the easiest way of doing it. Then we need to add the nut, the yellow nut. I have also put a color onto that one. Can find it here. I'll place it from my folder where I have done my stuff. This one. Again, I'll click a random place, leave it here. Press OK, and it is now flying freely here. And I want to add it to this threaded shaft. So we could do two things. We could of course use joint again if that's what we want. We have the options here. I guess the proper one would be a cylindrical option we could use. We can try it out. We have to pick the movable part first, so that would be this one and two. That one, you can see it's actually moving in, and it is a cylindrical option. And we can add limits here if that's what we want. Another way of doing it is using the constraint option. So we want to mate the center axis to the center axis of the nut. Seems to be okay. Accept it. We can of course, if I cancel this now, you can see we can move it in and out, and it can turn around. So if I now add another constraint here, this surface to that surface, and add a distance. I was mentioned something with should be movable from 10 to 85. So we want a distance in here. So I'll write 10 here and apply. Okay. Go directly to OK, and then it is on here with mate. And we can move it around. If we want to control it a little better, we can do that. Find the origin for the sub-assembly, and for the nut we can add another constraint on the nut, maybe the exit plane to let's find a proper plane on the other part, maybe also exit plane on the sub-assembly, like that. So we now constrained two planes, so we can't actually turn it now. If you want to turn it, we can always suppress this one. And then see, it is again turnable, we can see. Next, we'll have a look at this option. We have to where we can move it from 10 to 85. Let's have a look at that one. If we move to my constraints, make constraint 10 millimeters. If I now edit this constraint and edit some limits to it, then I can activate maximum and minimum. Minimum I'll stick with the 10, and then maximum I will add 85. So now we actually got limits on. See, when we are dragging in it, we can move it those 75 distance. We haven't made a fancy constraining here where it actually is turning, and we have to look more into other constraint types, movable motion constraints. But we got what we want basically. If you now move into this mate constraint, I have a right click on it and press drive. We can actually simulate what it does here. We can make a drive on it back and forth. We can also record it if that's what we want. We can also choose how many times do we want this. Pick 10, it'll carry on like that. and it's start end, so it starts going back to start and going to the end. If we pick the other option, then it'll move back and forth nice and slowly. So it seems to be okay. So this will conclude the video with assembling the part. The next video I'll look into the drawing.